Hey everyone, and welcome back to the channel. Today we're diving into something that can make or break your drone flying experience, properly configuring and tuning your Arducopter from the ground up. If you've ever struggled with a wobbly, unpredictable drone or felt overwhelmed by the hundreds of parameters in ArduPilot, this video is for you. The traditional approach for tuning drones can be frustrating, jumping between different documentation pages, not knowing which parameter to change first, and spending countless hours on test flights that don't seem to improve anything. But what if I told you there is a better way? A way that takes you step by step through the entire process, shows you exactly what to do at each stage, and gets you flying tuned aircraft with minimal flight tests. Meet the ArduPilot Methodic Configurator, or AMC for short. This incredible software was developed by ArduPilot experts specifically to solve the tuning headaches we've all experienced. Here's what makes AMC special. It guides you through tuning your drone in a carefully designed step-by-step process that's both efficient and well documented. No more guessing which parameter to change next, no more wondering if you're missing something critical. Before each step, AMC shows you the relevant documentation so that you know exactly what you're doing and why you're doing it. You're not just following blind instructions, you're learning the reasoning behind each configuration choice. The best part? AMC ensures you complete all necessary steps in an order that dramatically reduces the number of test flights needed for a successful tune. We're talking about going from potential dozens of trial and error flights down to just a handful of strategical test sessions. For beginners, there's a simple mode with just 17 required steps and only 2 test flights to get your drone flying smoothly and safely. In today's video, I'm going to walk you through the entire process from start to finish. We'll configure a brand new Arducopter setup, and I'll show you exactly how AMC transforms what used to be a complex, time-consuming process into something straightforward and manageable. We'll cover hardware setup, parameter configuration, those crucial test flights, and by the end of this video you'll have the knowledge to tune any Arducopter like a pro. Alright, let's dive in and turn your drone into the smooth and responsible aircraft that it was meant to be. This video explains some of the new features of ArduPilot Methodic Configurator 2.0. On this release, we introduced something called the Simple Mode that makes it even simpler to operate the software and configure your drone. You start by connecting the drone to your computer, and then you launch the software. So the software starts, and then you see the familiar interface where you can select a new project or open an existing one or reopen a project. We are going to start from scratch, select the template first. We want to use the Olibro X500 V2 because it's close enough to the vehicle that we are using. Then we want to give the name to your vehicle. So in this case, I will just call it test 2. We are not using any of these options. And then you just press create vehicle configuration directly from template. So dismiss the pop-up. The software started right now in the normal mode, but your software, if you install the new 2.0 version, will default to the simple mode. You can switch between them by using this combo box here. And on the simple mode, a lot of options are gone, so it's simpler to configure. Start by the takeoff weight. In this case, this is a very small vehicle and it's 1.2 kilograms. Maximum takeoff weight is also 1.2 kilograms. It's not using ppm. We are using all the protocols. Telemetry connection is connected to serial 1, Mavlink 2. The battery monitor is analog with analog voltage and current, so that's already correct. The LiPo voltage is also correct. On serial 2, we have connected the FITEC one wire protocol. We have 14 poles, 10 inches propeller, and ABS is connected to CAN, and the protocol is incorrect. So we need to select the correct protocol, drone CAN, and that's it. So we've now reached the end, save data, and start configuration. It will open your browser automatically with information on how to configure the orientation of your flight controller. It also presents you the information on how to use the software on this pop-up here. The same principles apply for the normal GUI or the simple GUI. You have to read the documentation, then you edit the parameter values and their change reason. You use the delete and add buttons to delete and add parameters if necessary. And once you're done, you press the upload selected parameters to the FC. Let's close it. So we are starting with all parameters at their default values. The correct value for the board orientation in this case is yaw 90. You can see here all the possible values, and this is the current value. This will be the new value. Just upload, press yes. You can fully ignore anything that's in gray because it gets automatically set. It opens information on your browser on how to configure your radio. Did that automatically. You should read this documentation and then go back to the software and select the correct configuration. In this case, I want here disabled. I want this one to be lost copter. I just have to search for L, lost copter sound. The next one I will set to motor emergency. And the RC9 I will set to scripting 1. Scripting 1. I don't have RSS type. We'll now correct the change reason. It's default, so I don't need to change anything in there. Everything that's default, I don't need to explain why I'm doing that. But anything else, it's good to explain why you did that change. So we're done. Upload, go to the next one. Then uploads to the flight controller. Then it opens automatically the documentation for the next step. In this case is the telemetry. And you read this thing, and once you've done reading that, you can go back to the software and configure the step. In this case, we have the CTS and RTS set to auto, but we want to enable it because we know that our modem uses it. This is the baud rate of our modem. Whenever it requires the flight controller to get the reset, it automatically resets the flight controller, and it also tests if the parameters have been correctly uploaded. Now this is for your ESC. For ESC, there's a video here that you can use. There's some settings for BL Heli. If you're using other software, you need to get the configuration software for that ESC type. There are multiple ESC types supported by ArduPilot. Go back to the software. So for the slew rate, we're using 25 to make sure we don't have cycle dependencies. The PVM max will be 2000. We're using FITEC, so it uses values between 2000 and 1000. For the LEDs, we need 231 because we have here 4. And the S max, we're using 1000 because this X max is a little bit different from the other one. The scaling is different. This is outside of the range, but never mind, it works fine. For the number of poles, it's 14. We don't need to change that. And these all need to be changed to 2000 and 1000. Yes, I want to use the out of bound values.
RPM mean in this case is 1000. And we'll keep the takeoff slow time at 2 seconds. So we don't change that. Need to explain here that this is for the here tree. Write it to the flight controller and go to the next one. Yes, this value is out of bounds and we still want to use it. Now we arrived at the battery monitor. There's information here about the battery monitor and how they can be configured. You should read this information, and once you do, you go back to the software and configure it. Okay, we'll start by the multiplicator. This is 18.6. The critical is 800 milliamperes. We are going to use the sag compensated voltage and set the low milliamperes to 1200. The other multiplicator is 20.6. So this is for safety. This is also for safety. Okay, and here is because we're basically not computers. So we have a FC that calculates the voltage for us. So we should use that. Internals battery resistance is a nasty stuff, and lots of beginners have problems with that, understanding how it works and what it implies. So it's a lot easier to just put these to sag compensated. You of course need to have a proper voltage measurement for it to work and a proper current measurement for it to work. But if you do, it's a lot simple to operate a vehicle with these things configured like this. So we're done. We can save it and go to the next one. Needs to reboot, so it will reboot. So whenever it needs to reboot, it does that automatically for you. You don't need to know if you need to reboot the FC or not. Now we move to the GNSS, so GPS receiver. Again, you have information here and here about how to configure your receiver and what receivers are possible and how to connect them to the flight controller. All the information is here. Just need to read it. And then switch back to the software. Right, port safety. In this case, it does not have one, so it's disabled. Here, it's drone CAN. Then the P1 driver is enabled for the first driver. Then the GNSS mode, we're going to double click here and select only GPS, SBAS, and Galileo. So this is what's recommended for Europe. So that's why we're using that here. And here we put the offsets to 0 because the GPS is really close to the center of gravity, so we don't need to have all of these things here. Now you see that some of these things are marked as not available on the flight controller. In this case, because we are using the latest version, 4.6.2, and these parameter names have been changed on the 4.6.2. It's very easy to correct that. You just need to add those parameters here. So you add, it's called GPS 1, and then pos X. And then you add another one called GPS 1 pos Y. And you add another one, GPS 1 pos Z. Then there's GPS type that's also missing, so we are going to add that one as well. GPS 1 type. GPS mode is still missing. Add GPS 1 mode. So now that I have all that, I can put here 7, or I double click on it and you get this other menu here. Either way, you can enter the number or double click it. The positions are all 0 as we said, and the GPS type should be drone CAN. So now we can delete these old parameters. And we can upload it. Again, it needs a reset of the flight controller because it changed the way the GPS is connected to it. Now we are going to the initial parameter calculator. So this was a plugin developed by Sean and some other people that integrated it in Mission Planner on the Autopilot Methodic Configurator. You already entered the propeller size, so all of this gets automatically done. You don't need to do anything here. Every single parameter is grayed out. That means that every single parameter was automatically calculated. So all you need to do is upload selected and advance to the next parameter file. We've reached a step where you need to do changes using Mission Planner. We need to close this application and start Mission Planner to do these steps. Now I'll start Mission Planner, do the steps in Mission Planner, and then go back to the application again. Connect to the device. The instructions that you need to follow are already posted on one of the pages that it opened in the background. You start in section 6.9, configure mandatory hardware parameters. You're supposed to open Mission Planner, connect to the flight controller, and select setup mandatory hardware, and then work yourself through the menus as described below. So we're starting by frame type and so on. We're going to go all the way doing all of these as described here on this page. Cell calibration, compass, radio calibration, and so on. The frame type, we're going to select quadcopter, and it's going to be type X. And then we're going to initial tuning parameters. Here we don't need to do anything because Autopilot Methodic Configurator already did this part, so you can skip it altogether. Then you need to calibrate the accelerometer and the level. For sake of brevity, I'm not going to do that right now, but you do need to do it. The compass, we're just going to use the main compass, but we calibrate all of them. Later on, we can still disable them, but we should calibrate all of them. So press start, do the calibration dance, and once it's done, you press accept. That's it. Once you're done, you go to the next one, radio calibration. You connect your radio, you bind it to the receiver on the flight controller, and then you move the sticks and see the limits here, and all of them should move, and you should check all the switches that you're planning to use. So if you plan to use like 9 channels, you should make sure that channel 1 to 9 work properly when you move the switches on your RC transmitter. Then the servo output, here you should select your motors. Usually just select motor 1, motor 2, motor 3, and motor 4. And later on, when you're testing the motor orders, you might need to change these things. Then you go to serial ports. We have them configured to Mavlink. We want to use FETEC on our ESC, so here we need to switch to FETEC. We are not using these two GPSs, so we table them as well in this case, because we are using a CAN GPS. We're done. ESC calibration. We have already set the PWM mean and max. It's already correct. You should set the spin mean and spin armed and spin maximum values correctly. And on this case, because we are using FETEC, you can just leave the ESC type to normal, and that's it. Flight modes. So if you want to change the flight mode to something else, you should do. I'm just going to use alt hold here and loiter here. And as flight mode 4, I want RTL, and that's it. Save modes. We're done. Fail safes. We do not have any propellers or battery power on the drone right now, so everything is safe, and that's it. We have done all the things that we need to do on Mission Planner. You can close it now. The changes you did in the steps above have been stored in the flight controller. Most of the change parameters are vehicle instance specific, so things that are very specific to this flight controller and you cannot reuse on another one, like accelerometer calibration or magnetometer calibration. So it's time to move to the next step. So let's open the software again. It connects to the flight controller. and then you should select that you want to open the last used vehicle. You do not need to start something new. We already have one. So let's save date. All the changes that we did in Mission Planner are here, so we can just upload selected parameters to the FC and advance to the next parameter file. We've reached the general configuration step number 13. Here is the documentation for it. We want to delete board heating target. This flight controller does not have it. The time zone is 60. It's not because it's Belgium, but because it's, in this case, Berlin. Baro fence type, we're going to change that. I want to also add the mean altitude, and I do not want this one. This is again for my application. Your application is different. We're going to keep all of these at 0 because it's pretty close to the center. And if the values are really small, they just add noise. So set them to 0. The loiter time, reduce that to 1000. So that's it. We will now it's time to configure logging. This is the documentation for it. The only thing you need to do is set this bat log count. In this case, we're just going to keep the default. This is a bug that I think it has been fixed. We're going just to keep it with the default. All the other parameters are automatically set by the software. You don't need to do anything. Just upload. The next one are the motor parameters. You can use this AutoPilot Trust Expo web application where you enter the ESC signal data here, thrust date and voltage and current, and it will then calculate the motor thrust expo. And if you want to adapt the way the curve fits, you need to change the motor speed mean and the motor thrust expo to fit your needs. Once that is done, you set the values here. We have 6.8. So we have a thrust stand that can measure motor thrusts for motors up to 25 kilos. So we measure that and we can calculate this thing very precisely. We can go to the next one. This is an optional PID adjustment that you can do if your vehicle is very large or very small. Then you can adjust the PIDs before the first flight. We're going to keep them all at default. We're not going to change anything because our vehicle is 1.5 kilos, so it doesn't need anything. It will fly with default parameters. It will not fly great, but it will fly. Now we've reached the notch filter setup step. Some more documentation about it, explaining what it does, why it's supposed to be used, and how to configure it. We want to use fast sample on both IMUs, so this is correct. It's already enabled, it's already at the approximate frequency of the noise. It's already using the ESC telemetry. On the notch options, we can double click on it. Multi-source, that's fine because it will use the FETEC. Update that loop rate, this is probably not a good idea. We are running at 400 Hertz and we don't need any more, and we don't need triple notches. So we can just close it and go to the next file. It will enable the notch filter, it will reset the flight controller, it will set all the parameters again to make sure that all of them get these values. Now it's time to perform the first flight. There's information here on the gyro noise, information here how to do the notch calibration. Follow the procedure described on this webpage to perform the first flight. Make sure to only use stabilize mode to take off. And on our webpage here, there's information on what you need to do. You need to assemble the propellers and perform the first flight and do the small short test flight hover for 30 to 40 seconds in altitude hold. Do not use any other mode. And then check for the motor temperature, motor output oscillation. Follow the procedures that is explained here. This is an example of oscillation on the output. If you have something like this, you have a problem and you need to address it. If your signals are not as noisy as these, then you're fine and you can proceed. So this is an example of a normal operation, and this is an example of a noisy operation. And once you've done that and you analyze the noise using the web tool, you can click here, managing gyro noise, to get the information about that. You can click here to take a look at the ArduPilot filter review tool. That's this one here. So you load your file and then you analyze the noise peaks here. And where you see the first noise peak, you put the frequency and the bandwidth of that noise peak. And then the notch filter will go in there and carve out the noise on that frequency band. Take a look at the attenuation that you're required, the minimum attenuation that you're required, the bandwidth that you need, the ratio between the minimum frequency of the peak and the frequency where the peak hits the maximum, the number of harmonics that you're required. You can double click on it and select how many harmonics you want. The options and the notch reference. This is required if you're not using S-telemetry. So on S-telemetry, you can set this to just to 1. You don't need to use this formula here. But if you're not using S-telemetry, you need to use this formula here to calculate this value. Once you're done, upload, go to the next file. It's now time to configure the throttle controller. So the Mixman, once you've learned the motor thrust hover, should be set to 0.5. It will automatically calculate them using these formulas and set them here. But you need to have done the flight. I haven't done the flight right now. This time you need to use a Lua script to do the quick tune. It will automatically download that Lua script from the internet if you select yes, and then will automatically upload that script to your flight controller if you select yes. So it got it from the internet. It will now be sent to the flight controller, and now it's time for the second flight. The parameters are going to be set to prepare the quick tune script, and after that you can do the flight. So all the parameters have their defaults. The most important thing is that the quick tune has been enabled now and the script has been uploaded. So all you need to do here usually is to press upload. There's some documentation here about what the quick tune is and how it operates. So you can click these links and you can read more about it. It detected that it automatically needs to reset the flight controller. It will do that, upload all the parameters, and then you're ready to do that second flight. This configuration step requires external changes. You need to do the flight, and the quick tune will change parameters on your flight controller. Select close, you do your flight. Once you're done, you come back in and you start the software again. Software starts, downloads all the parameters, including the ones that the quick tune script just changed. We'll use the last vehicle configuration directory and save date and start configuration. It asks you, have you done the VTOL quick tune script? Select yes, you've done the flight. In your case, the values will have changed by the quick tune, and you will see different values here. Press upload. So this is the very last step. This is for productive configuration. So we're going to set the throttle mix max because it's now everything is configured. you can set this thing a bit higher. We're just going to set that to 0.7. The battery failsafe low, we're going to be RTL. We do not have a battery too, so we're going to delete that. The log bit mask will stop logging all those notch filters and stuff that you no longer need. So it will just log less stuff. Your log files will be shorter. In our case, we do missions inside a hangar, so our RTL altitude needs to be really low. So I'm going to set this to 500. But again, you need to set this to your specific needs and your requirements, and they are different from mine. So we're done. We've done everything. Load select and advance to the next one. And that's it. We have now reached the end. So we did the methodic configuration of 1996 parameters from Ardocopter 4.6.2 beta 2, and 980T kept their default value. Then 8 non-default writable sensor calibrations. In your case, there will be a lot more. I skipped a lot of things here, that's why there's only 8. And 94 non-default writable non-sensor calibrations. Those are the ones that can reuse between vehicles because they are not depending on the vehicle sensors. So that's it. We're done. It automatically creates a zip for you so that you can send that zip to me or to somebody else to inspect, to help you and stuff like that. That's it. It closes the software automatically. You're done.
And there you have it. We've just taken a brand new Ardocopter setup and transformed it into a perfectly tuned, responsive flying machine using the Ardopilot methodic configurator. What we've covered today represents the essential 17 mandatory steps that every Ardocopter needs for safe, stable flight. These steps provide the biggest improvements to your drone's performance and are absolutely critical for getting your aircraft airworthy. Now, here's something really cool about AMC. What we did today was just the beginning. We used the simple mode, which focuses on those 17 essential steps. But AMC also has a normal mode that can take you much deeper into optimization. In normal mode, you have access to 36 optional configuration steps depending on your specific needs and how far you want to push your tune. The beauty of this system is that it's designed with diminishing returns in mind. The first 17 steps, the ones we covered today, give you the biggest bang for your buck. The remaining optional steps offer progressively smaller improvements, but they can be valuable for specific use cases or when you're chasing that last bit of performance. Everything is arranged from most impactful to least impactful, which means you can choose to stop the tuning process whenever you're satisfied with your drone's performance. Maybe the 17 essential steps are perfect for your needs, or maybe you want to dive deeper into those advanced features like system identification or analytical PID optimization. The choice is entirely yours, and that's the beauty of the methodical approach. If this video helped you get your Ardocopter flying better, I'd love to hear about it on the comments below. Share your success stories, your challenges, or any questions you have about the tuning process. Speaking of which, if you want to dive deeper into Ardopilot configuration, check out these related videos here. Now get out there and enjoy your tuned Ardocopter. Safe flying everybody, and see you in the next video.